So this quarter we'll be looking at a variety of ways to depict three-dimensional scenes onto a two-dimensional surface, but of course focusing primarily on the rules of linear perspective and the concept of using converging lines to depict and represent parallel edges that are diminishing and extending into a three-dimensional scene. Of course, linear perspective can be broken down into three general types of drawings: 1-point, 2-point, and 3-point perspective. And let's use this example to illustrate the differences between the three. Here's three views of the same geometry. In this case, a cube, and primarily the difference between these three views, I think you can tell intuitively, is that it's the relationship of you, the viewer, and or the station point relative to the geometry in the scene. So in this case, a cube again. And in 1-point perspective, that's shown here, we're looking essentially head-on at one of the major faces of the geometry. In contrast to 2-point perspective, shown here in the middle in the green cube, 2-point perspective, it appears as if the station point or viewer has moved relative to the cube, and now not only are we seeing one surface, but now we're seeing a second surface of the cube. Okay, and then obviously I think you can connect the dots and see that in a 3-point perspective, now the station point or you have moved relative to the geometry, so that not only are we seeing the front face that we were seeing initially, but also the second face of the cube that was revealed back in the 2-point perspective, but now we're seeing the top of the cube as well. So that's the build-up from 1-point to 2-point, and then now 3-point perspective. It's essentially the change in the position of the viewer and picture plane to the three-dimensional scene. So this picture plane term that you hear me throwing around a little bit can really be thought of as just that. Imagine a picture frame through which that you're seeing the three-dimensional world, and then imagine that you can project the three-dimensional world onto this two-dimensional surface that you're holding in front of you. That's essentially what a picture plane is. And you can imagine then in the previous examples where we're looking at the cube and rotating around a three-dimensional scene, then your view would change, and then of course the drawing that would result on your picture plane would also change. But let's dive in here and take a look at how 1, 2, and 3-point perspectives are built and constructed. And in a 1-point perspective, you can see that the majority of the edges that are in our scene are not receding into three-dimensional space, and in fact are parallel to our picture plane. And the rules of linear perspective dictate that the edges that are not receding into three-dimensional space will be depicted as parallel and will not converge. So here you can kind of see the edges that are parallel to our picture plane and will not converge in our drawing. However, there are some edges that are receding in three-dimensional space, and those edges are going to be shown as converging lines that in this case converge to a very specific point that we call a vanishing point, and we'll abbreviate that throughout the quarter as a VP. And if that if those edges that were shown as showing as converging lines are in fact horizontal edges, then that vanishing point, let's do that again. Will in fact that vanishing point will reside on an imaginary horizontal line infinitely far away that we call the horizon line. And one thing to note too is that once you have a vanishing point, then too these edges can be projected out of the scene as well to extend the perspectival system further into the foreground. So here I'm drawing kind of a larger square closer to you and the viewer that extends the perspectival space closer. In a two-point perspective, in much the same way as before, edges that are parallel to the picture plane and not receding into three-dimensional space, in this case only the verticals, we'll show those and draw those as parallel lines that are not converging. However, in the same way as before in the one-point perspective, there are edges that are receding into three-dimensional space and would converge at a common point in the scene. And so here we're going to just note this as one of our vanishing points. So here's our first vanishing point. But unlike one-point perspective, we now have a second surface to deal with, and it too has edges that recede into three-dimensional space. However, they converge at a very different point, and this is vanishing point 2. And of course, in the same way as before, if those edges, and in this case I've drawn 4 edges, are all horizontal lines, then the 2 vanishing points will reside on a horizon line. So here is my horizon line, abbreviated HL. So this is my 2-point buildup. So moving along, I think you can kind of see what's happening here in a 3-point perspective now. None of the major edges in the scene are parallel to the picture plane. They are all converging to points in the distance. And here I'm going to just roughly locate one of the vanishing points. So here's my VP1. And then similarly as in the 2-point perspective that we were drawing previously, do that with a little bit more care. There is a second vanishing point to consider that represents the point to which all of these edges are converging. But in a 3-point perspective, obviously there's a third point to consider, because as our station point and our position has moved higher than the geometry in the scene, the vertical lines are now looking like and need to be depicted as converging lines as they recede into 3-dimensional space. So this is my buildup of a 3-point perspective.